Now let's quickly write the Python implementation for the algorithm that we have discussed previously for finding the minimum value in a sorted rotated array. So here inside this function declaration, whatever I have done, first let me just read the length of the array that we have got so that we can be it can be useful wherever we want. So first of all, let's just assume whatever the array that we have got is not at all rotated. It is sorted, but the elements are not at all rotated. In that case, to return the minimum value, what I want to do is I want to compare the value at 0th index. If at all the value at 0th index is less than the value we have at the last index, if at all that is smaller, I mean the first value, that is element at 0th index, is smaller than the last value, then basically the array is sorted but not rotated. In that case, to return the minimum value is nothing but whatever the value we have at the 0th index. Okay, this is Python, right? So I should not use this curly braces, rather I should be going with this approach. Anyway, now if at all the array is rotated, in that case we need to apply the binary searching. So for binary searching, let me just define helper variables start and end. This end will be nothing but last index, and along with that we will also define middle with -1. Now here what we will do, we will run a loop as long as start is less than end. What we will do, we will calculate the middle. So to get the middle whole number, let's just import math. Here let's do math dot floor of start plus end divided by 2. Okay, once we get this middle, what we will do is, in all our previous comparisons, basically we were comparing equals case, right? Here it will not be there, since we are trying to find the minimum value. Ultimately what our aim here is to move the start index to the index which has the smallest value in the sorted and rotated array. So for that, what we will do here is, if at all the value we have at the middle, if it is greater than the value we have at the end, that means the last value in the search range is smaller than the value we have at the middle, basically the rotated array lies on the right part of it. So the minimum value will also lie in the same one. So to continue the search in that right part, we will simply update the start with middle plus 1. If this is not the case, then here we will update. See, whatever the middle that we have is basically less than or equal to the value we have at the start. So whatever the value we have at the middle, it could be the smallest value as well. So here, to continue to consider that middle value also as smaller value, in a worst case, we will simply update the end with middle itself. In this case, logic still goes on. Once we exhaust all the ranges, whatever the value we have at the start will basically hold the smallest value. So in the end, once we complete the loop, we will simply return array of start. Okay, so that is the simplest implementation of finding the minimum value in a sorted and rotated array. So here basically, if you see, the array of values that I have passed are 4, 5, 6, 2 and 3. Basically the sorted array was 2, 3, 4, 5, 6, and I have rotated it twice, so I have got 4, 5, 6, 2, 3. Out of this array, the smallest value is obviously 2, right? So if I run this program right now, the output should be 2. So run code, the output that I have got is 2. Let's just say I have deleted this 2. Okay, rather I have the value 3. So right now the smallest value is 3, right? So if I run the code now, the output should be 3. Okay, that we have got as well. Let's just say the array that I'm passing is not at all rotated, basically rotated 0 times, right? So that means all the values will be sorted in the ascending order only. So if I run this code right now, the output should be 4. That is what we have got as well. Okay, so whatever the logic that we have written is working fine. If at all, if you want to test for a couple of other scenarios, you can go to codingpal.org. There you can find few more test cases different from what we have already executed. You can execute them and validate too. Okay, anyway, that's it for finding the minimum value in a sorted rotated array using binary search technique.